Good morning, dear students. In the previous class, we have discussed about first of all mechanics, in the its mechanics types, and then this mechanics mainly describe the motion and rest, and both of motion and rest will be explained by the frame of reference. Those things you have learned in the previous classes. Now, today class, the basic of motion and rest is explained by sum of terms, and that sum of quantities is length of distance or path of length, displacement, velocity, acceleration. Those things you have the learn with as much as details. Today in this video you have the describe the difference between path length and distance. In generally, most of the students are confused about or between the distance and displacement. In generally, these distance or displacement both are the same, but in according sum of properties, it must be difference. The main property, that is a scalar or vector quantity. Okay, how can define the path length or distance? Both are the same. The total traveling length by object. The total traveling length traveling by the object along in motion, that is taken as path length or distance. This is denoted by D letter. At the same time, displacement, it is the shortest distance of the object in the motion. So object distance of object, that is taken as indicated by capital S. And one more thing is, the path length is a scalar quantity. Scalar quantity. Scalar means it have only magnitude. It means it has some value. Suppose 10 newtons. In this case, this n is denoted units. This 10 number is gives the magnitude. So all the numbers are the magnitudes. All the numbers is the scalars. So scalars means it have only magnitude, and there is not have direction. Vector means it have the magnitude as well as direction. Then that physical quantities you have says vector quantities. And one more thing is, suppose what is the object or particle at the starting point taken as initial point. At this point, you have the taken time is 0, and that point is taken as x1. And then it moves with the span of time, then it reaches another point. That point is taken as P2, and that is the taken as final point. Then it is indicated by distance is h2, and that time equal to small t1. Suppose you have to assume it. Then this is the one of particles moves this p1 to p2. It's have a more than one of waves. For suppose is the one of wave. At the same time, another wave I have taken like this. This is also a traveling direction or path. Another will be possible that is suppose taken as it. In another way taken as like it. Suppose it is taken as path 1 or it's path 2 and this is the path 3 and this is the path 4. You have assumed it. Okay, see, it clearly says that the path 1, this path 1 taken as displacement because the shortest distance between these 2 points. 2 points means initial point and final point. Now see, the path of P2 and P3 nearly equal. So this P2, P3, P4 taken as the distance. P3, P4 and P2 is the path taken as the distance. The path P1 is taken as the displacement. And one more thing it already says that this P1 is depends on the final and initial point. Final and initial point. Then out of P1, those paths does not depend on the initial and final point. That's the thing. Those means P2, P3, P4. It does not depend on these points, means initial and final point. But displacement, so path 1 depends on this one. So that's why the distance is called as path dependence. It depends on the path. So displacement not depends on the path, so it is taken as the path independent. But it depends on the initial and final points. Initial and final points. That's the most important thing. And one more thing is, this unit is in the SI system, is the meters, the same thing, displacement also, the units is the meters in the SI system. Its the dimensional formula is write down as m0 L power 1 T power 0. Same thing, m power 0 L power 1 T power 0. That's the thing. Next, you have value of or magnitude of the displacement. It will never be 0 when the object is moving. It's the most important condition. When the object is in the motion, its displacement never be equal to 0. It must be positive. So distance is the positive values and never be 0. If it will be 0, it means that body will be at rest. That body will be at rest. Then the displacement, its value may be negative or 0 or positive. Whenever it gives values negative means, see, suppose you already know the number axis. In this number axis, the middle one taken as 0, its value is positive and this value is negative. Suppose one of particle is starting at this point and goes. Suppose this is the O, this is the P and this point is Q. Suppose one of our body or particles goes to the O to P, then again it return P to Q. Clearly observe it. Suppose one of object is motion starting at point to O and reach P. Then again it returns come to the Q. Now you have the calculate the displacement. Then displacement is must be known, that is depends on the initial and final point. Now this will be initial point, then it is the final point. In this number axis, its value is negative. That's the meaning of negative value of displacement. Means negative means it goes to the opposite direction to the initial situation or initial state. That's the thing only. Okay, next, whenever it value is 0, it means if initial and final point coincide at the same point, then its magnitude of the displacement will have taken 0. Then it goes the forward direction, that magnitude is first. This is the thing or occurred in the displacement. Okay, this is the distinguish or difference between the distance and displacement. In this class, we have described or explained some more problems based on this displacement and distance. Now we see, suppose this is a semi-circle. At this point taken as the origin O, this to this, the radius is capital R, and this. So the radius is capital. Now its displacement is taken as, suppose if point is A, if point is B, the shortest direction or length, that is one is this one. So length of AP, the line of AB. So line of AB is equal to 2, because this will be R and this will be R. The total is 2R. Then distance. This distance you have calculated by the circumference. So semicircle circumference is πr. So it gives us arc of AB. Arc of AB gives its distance. Line of AB gives its displacement. This is the same thing if taken as one more 2 points on this semicircle, that is the P and Q. So make some angle with origin, that is taken as theta. Then is the displacement taken as the line of PQ. This line of PQ is equal to, see, suppose now it is taken as a one of a normal line. Now it is will be like as rectangular triangle. Suppose it is the R. Then use the trigonometry functions. Then it gets this value is 2R sine theta by 2. Okay, that's the displacement. And the distance, its distance is r theta. Capital R. This is the difference between distance and displacements. The same thing applied. For example, this is the rectangle triangle, and take is a diagonal. Suppose it will taken as 4 meters and this is 3 meters. The distance of this point to this point, the distance taken as this length, suppose the A, B and C, distance is taken as AB plus BC. So its value is 4 plus 3, that is given as 7. But to use the magnitude of displacement must to be remembered. The point is, whenever asking about the displacement at that time, you must to be remember point is it depends on the initial and final point. So just you have the taken the distance between A to C. This is like as right angle triangle. So according to this formula, the root 4 square plus 3 square, it gives value is 5 meters. That's the thing. So this is the difference distance and displacements. Okay, students, please comment on use the, if suppose it's taken as a circle, then what is this displacement and what is this distance? This value how they post on the comment box.